So in this video we are going to learn the different types of number systems in the digital electronics. So in these we having a methods, a simple methods to convert a binary number into a decimal number, and there are different type of conversions and that can be learned in this video. So firstly, when it comes to the binary number system, so when it is the binary number system, the symbols are 0 comma 1. So these are the binary number systems which can be 0 comma 1. And the radix means base. The radix is base, the other name of radix is base, is 2. So the 0 comma 1 is the symbols of binary number system and the radix is 2. And the next we can discuss about the octal number system. So in this we will be having 7 8. Octal means 8, right? So in this having octal number system, so in this we will be having a symbols called as 0 1 2 3 4 5 6 7. That's all, up to the 7. These are the including 0, we call it an 8 numbers totally in this symbol. So we can convert an octal number system into a binary number system, a binary number system, an octal number system. And the base or radix is 8. We must supposed to read the base in the form of radix, which is the word which is used to represent the base with the other name. So in this, the third number system is decimal system. So in this decimal system, we will be having 10 total numbers. So their system is 10 total numbers up to 0 to 9. So 0 to 9 are the 10 numbers. So examples can be taken as 2 3 1 0 5 6 9 8, base or radix 10. So in this radix 10, so in this example whatever it is, base is 8 and is whatever 0 comma 1 and base is 2. So these are the examples of an decimal system, and which is one of the part of a types of number systems. And the next is we are going to discuss about the hexadecimal. So in this hexadecimal, the name itself, the hexa means 16. So the hexadecimal system, we will be using the symbols called as hexadecimal system. So in this we will be using the symbols are 0 1 2 3 4 5 6 7 8 9. And after we won't repeat 10 in this number. So to in the form of 10 we will be writing A, B, C, D, E and F. So in this A is 10, B is 11 and C is 12 and D is 13 and E is 14 and F is 15. So F is 15 in this. So let us do the conversion types now. Let us assume that the conversion of number system. So in this we will be conversion of different type of numbers into the different type of number systems. So in this the number system, so let us assume. So first let us convert the binary to decimal. So binary to decimal, let us convert first. So in this binary to decimal, let us take an example number called as 1011. It is of the form of binary, so we have to convert this code to the decimal. So the decimal base is 2. So sorry, the binary radix is 2, but to convert it into the decimal we have to supposed to use the 2. So it is a very key role which plays. So let us assume, so there is two methods in this to solve this question. So the first method is always taking the numbers 1 0 1 1, and on top of it we are placing the radix 2 2 2 2 whole powers, and on top of it we are taking from here right now and 0 1 2 3. So the next step we have to write is 1 into 2. From here we have to write, so 1 into 2 to the power 0 plus, and 1 into 2 to the power of 1 plus 0 to the power of 2 and plus 1 is to 2 to the power of 3. So this is how this is the first method which is used to convert a binary to decimal. So in this, so 1 into 2 power 0 is 1 plus 1 into 2 to the power of 1 is 2 plus 0 into 2 to the power of something by into 0 is 0, and plus 2 into the power of 3 is 8. So totally the answer is 11 to the power of base 10. So to convert, so the given binary number, it is of the form of base 2. So to convert the binary number base 2 to the decimal number base 10, this is the procedure which is used. And to convert if in the case if a person knows the radix of decimal, so which can be easily converted by using the second method called as 8421 binary code. So 8421 binary code, which is very useful for an engineer to be convert the given number into another number system. So in this we will be converting the given number, like the given number is 1011, right, here in this. So 1011, so 1011 it matters here. So 1011, let us place it here, 1011. This is the binary code which has to be exactly remembered. This is constant as always, and this is exactly has to be written there. So 8421, so in this case of 1011, if we write, so if we write in the given number or the given question into the form of 8421, so let us assume 8. So here we have to assume that wherever we find 1, so on top of the 8421 code we have to add those numbers. So here 8 plus 2 plus 1, so 8 plus 2 is 10, 10 plus 1 is 11. So it is easy to convert to the decimal, so binary to decimal conversion by using an 8421 code, which is very much useful to convert a given binary code into the decimal very much easily. So in this case we have learned to convert how to convert a binary to decimal by using two methods. One method is like this and the second method is 8421 code, and like that we have to supposed to use it. In this next case we are going to learn how to convert a given number into let us assume our one more example about this problem. Let us assume that in the form of decimal, so let us do the given binary conversion into a decimal in the form of by keeping a decimal point in between 1111.101 comma 2. So to convert these to something of base 10, so we have to use two methods. There are two methods, but here we can only use one method called as, so only first method we can use here. So we can be using the second method also, but in this case we can do it fast in the first method. So 1 1 1 1 comma 1 0 1. So here we have to place 2's for the same, everyone. So on power we have to place 2, and on the top, the whenever we will be doing a decimal number, we have to remember that this side is always allocated to the positive numbers and this side is allocated to the negative numbers. So this side we have to write 1 2 3 4 on top of it, and including, sorry, 1, so including 0 1 2 3, we have to write 0 1 2 3, and 1 minus 1 minus 2 minus 3 on top of it. So we have to multiply from here itself. So 1 into 2 to the power of minus 3 plus 0 into 2 to the power of minus 2 plus 1 into 2 to the power of minus 1 plus 1 into 2 to the power of 0 plus 1 into 2 to the power of 1 plus 1 into 2 to the power of 2 plus 1 into 2 to the power of 3, so equal to, let us write. So the first answer, 1 into 2 to the power of 3 is 1 by 8. So plus 0, something by 0 is 0, plus, so this answer is 0.5 plus, so 1 into 2 to the power of 0 is 1 plus 1 into 2 to the power of 1 is 2 plus 1 into 2 to the power of 2 is 4 plus 1 into 2 to the power of 3 is 8. So by converting the given number, 15.625 is the answer after converting a given binary number into a decimal code. So this type of a decimal code which is very much useful by converting it by using this simple method. And these are the different type of methods that can be easily used by converting a binary to the decimal number. So here in this case, next we are going to learn about how to convert a given octal or a given octal number into a decimal code. So we will be converting a given octal to decimal. So octal to decimal we will be converting. So we are converting the octal to the decimal conversion. So in this case, let us take one example, 4 5 to the base radix of 8. So this is the base of octal 8. To convert it to the base of 10, the decimal 10 radix, so to convert we will be using this method. So like this is the same method which is used previously, the first method also. So here 4 5, so let us write differently, and top of it we have to write 8 and 8, on top of it we have to write 0 and 1. So this is the easy conversion. First we have to be using the 5 into a to the power of 0 plus 4 into a to the power of 1. So this time we are be using to convert it. So 5 into a to the power of 0, a to the power of 0 is a 0, so a to the power of 0 is 1, so 5 into 1 is 5 plus 4 into a to the power of 1, so a to the power of 1 is 8, so 8 into 4 plus 8 into 4 is 32. So here 32, so total is 37 into the base 10. So the to how to convert by given number octal number to an decimal system, this is the procedure that how we convert, and this is the previous procedure itself, there is no change in it. So to convert the given number into an binary is very, very difficult. So let us assume, so let us do the same thing, 5 comma 8 8 to the binary. So to binary the numbers is radix is 2. So to convert this number into the binary we'll be using an 8421 code. So 8421 code, which is very much simple to understand by any person, that can be easily converted. Let us assume the 4. So in this case the 4 binary code is 4. So 4 is in this case we will be putting 1 0 and the leftovers are 0. So the 4 binary code is 0 1 0 0. So the 4 binary code is 0 1 0 0, and the 5 binary code, by how we get 5, by adding 4 plus 1. So here in this gate 8421, by adding 4 plus 1 we will be getting 5. So in this case we will be putting 1 here, and in both sides 0 1 0 1 0 1 0 1 is the binary code of this. The total binary code of 45, converting it into given number, converting it given octal number, converting it to the binary code, it is of the form of 0 1 0 0 and 0 1 0 1. It is a easy conversion of a method octal to decimal, or octal to decimal, or octal to binary. So these are the different type of methods which can be easily used to convert a given number or a given procedure, given decimal points. These are given decimal questions can be easily numerical questions that can be easily converted into a different type of methods by using a 8421 code, and this is the procedure, and the both procedures are very much useful. So make sure that everyone must learn about an 8421 code. So in this we are going to say about an 8421 code right now. So let us do 8421. So to get 1, so we are dividing it 1 1 0 1 2 3 4 5 6 7 8 9 10 is A, right? So here 10 is A, B, C, D, E, F. So let us continue. So 0, in this case we are we are putting all zeros because we don't have any such kind of number in the 8421 code that we can represent the 0 in there, right? So here we are having 1 in the 8421 code, so we are placing 1 here and the leftovers are the zeros, and this is the decimal code of this is the binary code of 1. So here in this case of 2, we are putting 1 here and the leftovers are the zeros, and this is the binary code of 2. And how to get 3? So by adding the 2 plus 1 is 3, so 2 plus 1 is 3, so we are placing 1 1 here and the leftovers are the zeros, and so this is the binary code of 3. And the 4, so when we go to the 4 we are placing only 1 here and the leftovers are the 0, and this is the binary code of 4. So this is the binary code of 4. So let us keep an arrow marks that can easily understand. So 0 1 0 0 is the binary code of 4, and to get 5, so how to get 5? 4 plus 1 is 5, so 4 plus 1 is 5, so right in the place of 4 and the 1 we are keeping 1. So and the leftovers are the zeros, and so this is the binary code of 5, and like that by 6. So how to get 6? 4 plus 2 is 6, and we are keeping 1 1 here and the leftovers are the 0, and this is the binary code of 6. And how to get 7? So in the case of 7 we have to put 4 plus 2 plus 1. 4 plus 2 is 6, and 6 plus 2 6 plus 1 is 7. So in this case 0 1 1 is the binary code of 7. So 8, so how to get 8? We are having directly here we are having 8 in the 8421 code. So we are putting 1 here and the leftovers are the zeros to represent the binary number of 8. So the next is 9. So how to represent 9? By adding an 8 plus 1 is we will be getting 9. So in the place of 8 1, and in place of 1 we are keeping 1. So the leftovers are the 0. This is the binary code of a 9. So let us assume the a in the form of 10. So how we get 10? So how we get 10? By adding 8 plus 2. 8 plus 2 is 10, right? So 8 in the place of 8 and the 2 plus in the place of 2 we are placing 1 and the leftovers are the 0. And this is the binary code of uh, a, or that's or 10. And the binary b is level. So how we get level? By adding 8 plus 2 plus 1. So 8 plus 2 is 10 and 2 plus 1 is level. So with the binary code is like this. So this is the binary code of level, and or b, or like that. So this is 12. So how we get 12? So by adding 8 plus 4 directly. So 8 plus 4 directly we can get 12. So 8 plus 4 directly. So in the place of 8 and 4 we will be placing 1 1 and the left also the 0, and this is the binary code of 12. And the next one is d. So the d is represented as the 13 number. So how do we get the 13 number? By adding 8 plus 4. 8 plus 4 is 12 and 12 plus 1 is 13. So in the place of 8, 4 and 1 we are placing here, and the left was the 0. This is the binary code of d, or 13. Or here e is represented as 14. So how we get 14? By adding 8 4 2 8 4 2. So 8 plus 4 is uh, sorry 8 4 2. So 8 plus 4 is 12. 12 plus 2 is 14. So 12 plus 2 is 14. We are having the only 3 and zeros here, and this is the binary code of 14. And how we get 15? The 15, the name is it is represented with the alphabet number called as f. So to represent f, we must supposed to add this all numbers. 8 plus 4 is 12, and 12 plus 2 is 14. 14 plus 1 is 15. So totally we are placing all ones here, and this is the binary code of 15. So if a person gives a number which can be converted into a binary code to a decimal code, or a decimal code to a binary code, which is very easily processed. So in this process we have learned so how we can discuss the 8421 code. So let us hope in the next class. Thank you.